Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schankelberg. Hey, Kirk.
Hey, Fred. Good to hear your voice.
Yeah, good to hear you again. And we were chatting before we got on it, and it sounds like you're getting ready to go to the Bahamas to hang out with your Bermuda shorts and all that good stuff. Can you wear Bermuda shorts in the Bahamas, or is that somewhere else you're supposed to do that?
See, Leo, no, you only wear Bahama shorts in the Bahamas.
Okay, yeah. So have a good trip. Hope that all goes well.
I'm looking forward to it.
Before you head off, I thought I got this note in LinkedIn, and I knew it was right up your alley, so we had to talk about it. And this guy said there's a shindig, in quotes, he put it, in Finland, and it's where he was part of the design team for the Nokia 9210 communicator, and 25-year anniversary was the shindig coming up. And he said this
is a product.
Yeah, right. This is a little phone type system. I think it's before flip phones even. We were talking about that a little bit.
Yeah.
A 25-year-old, and he says, I keep a lot of my old stuff like that, old stuff I worked on, especially. I keep copies of those laying around. So I dug it out, plugged it in, and it took 80% of its charge, and it fired right up. He said, it doesn't have all the bells and whistles and features of stuff today, but it works.
Right.
And he said, we knew, with the quote that I thought was great was, he said, I know we seriously over-engineered that. And he said, in part because there was no point of reference internally for that product class. We'd never made it before. So anything that was unsure, we made it more robust, is kind of the gist I got out of it. But it also reminded me, I wrote back to him, to Stefan, and I said, you got to see Kirk's article, the drain in the bathtub curve.
Exactly.
Kind of that.
Right. It sums it up, is that technological obsolescence comes well before electronic components use up their intrinsic life. And I mean, mechanical components are a little different. Especially if they consume material off each other, like gears and motors and
but there are motors. There's industrial motors that have been running for 50 years.
Exactly.
If they're designed well and maintained well and greased and stuff properly, they will last a long, long, long time.
Well, let's see. This I have a what's the radon gas mitigation system was installed in my house, and I don't know when. We bought it 10 years ago. So and the house was built in 83. I imagine in one of the sales between the 80s and 90s, there was a radon test and they found some. So basically that's pumping out from around the basement part and around the ground, I guess, a fan that constantly runs next to and it has an exhaust on the outside next to my fireplace, on the outside of the house. And
does that make the fire burn brighter or something?
No, it's not anything to do with it, because it's down in my basement that it sucks it out. But that thing has been running continuously, 24 hours a day, 7 days a week, for certainly over 10 years. And I go, when is that going to fail? I mean, is it going to fail?
No, it probably does. I mean, you've had power outages, so it's had to restart, right?
Right. Yeah.
So yeah, I know I've told the story, maybe not to you, but I was when I was way back when I was at Hewlett Packard, one of my colleagues was looking at spares. What suppliers are being used the most often in spares, and usually it was a 1-to-1 replacement. So if we bought XYZ company fan, it was replaced with an XYZ company fan. It was a replacement part. So because of the design specs and requirements and stuff. And he was looking for bad actors or for bad designs. But what stood out of all the data was this one company was head and shoulders more reliable than anything else. He says, we bought 10 spares 10 years ago and we haven't used any yet. It was kind of that markedly different than anything else.
Right.
And so I went down and talked to him and says, how do you do this? And he goes, do what? And he goes, how do you design such reliable products? Well, we test them. And this general manager had no idea how to answer my question. He had really no idea what I was talking about.
Yeah.
And so he showed me this along one of the hallways. They had this glass enclosed room with all these little shelves on it and all of the different fans they made, different model and families of
Uh-huh.
fans, little itty bitty, half-inch square ones that sit on top of
Mm-hmm.
a component to, ones that
Right.
feed the whole server and even bigger ones, some that were 12 inches on the side.
Uh-huh.
And they all had little streamers on them and they were all blown away and you could
Mm-hmm.
see everything was running. And he
Mm-hmm.
said, how does that help it's reliable? He goes, well, they've been running forever, I, but there's no back pressure. There's no cycling. There's
Right.
no
Right.
dust. And I said,
Right.
what's that great big box over there in the corner? It looks like an uninterrupted power supply. He goes, oh, yeah, we put that in there because it was cheaper than having our tech go in there and get them all spinning again after a power outage.
Oh, no.
It's like none of
That's
those had
one of
bearings in them
I
anymore.
know. Yeah. Well, I did, to be fair, I did replace recently the exhaust fan in my wife's bathroom.
Mm-hmm.
And I suspect because what I had to do, I mean, looking at the dust and everything, that it might have been installed when this house was built in 1983.
Yeah.
So, how many, what, 50, 30 years
Yeah.
or more, and it just had bearings, slowed it down. So it took, 5 or 10 seconds to start up. And so, of course, it's easy to see that it was about worn out.
Yeah.
So
And if
yeah,
you got up there and cleaned it every year, it would probably still be running.
exactly.
But that's a pain. They get up there
Yeah,
and clean a ceiling fan.
right. And so it depends on the maintenance, whether you're in the environment, things like that. But for the most part, yes, you can. And certainly motor technology is very ancient now. Electric motors have been around for what, hundreds of years,
Oh yeah, yeah,
50 years
120
more,
at least.
something
Yeah.
like, yeah. So, it's not, I'm not worried about, but what we're kind of getting to is, if you're talking about smartphones or even any handheld phone, the remote devices, what was he using to over design it? Was he, because, was it derating like you believe in of everything?
Well, they probably derated it. They probably did a version of Halt and fix stuff. They were probably worried about
Maybe.
dropping, because
Right.
that's
Well, yeah, tumble
and
test
making
where
it pretty robust. Yeah.
you put it in a big tumbler and you see what
See what
breaks,
happens, and then you fix it.
and that's the point I want to make is that it's not, are you getting anything out of your testing? You can always get something out of your testing if you look at it from a different frame of reference, and that is from the strength of what intrinsic strength of the electronic materials and system have and the operating range or margins, empirical margins, observable that
Hmm.
under stress that you can compare between samples, between previous designs, and that is you're going to get something out of all testing. And I go back to the quote from David Packard. It is absolutely true today as it was when he said it in 1972. Reliability cannot be achieved by adhering to detailed specifications. Reliability cannot be achieved by formula or analysis. Some of these may help to some extent, but there is only one road to reliability. Build it, test it, and fix the things that go wrong. Repeat the process until desired reliability is achieved. It is a feedback process, and there is no other way. And
Yeah.
that's what I want to say. Is
No, it was
the
built
big
into
thing,
It was built into HP.
right?
It was build, test, fix. That was the motto.
Right, but the testing is what I focus on. They're not testing to what they can. If the product is still, if you haven't tested it to where it won't operate, you don't have to destroy it. But if you don't test it under stress to where you have an operational limit, okay, you're not getting all the information out of it. It may break. Yes, you may get a catastrophic failure, and that teaches you a lot. But if you're not using all the strength in the product to find the weaknesses, you're really losing a lot of money. You're really leaving a lot of money on the table.
Oh yeah,
And that's
no,
my point.
I totally agree, and I have story after story after story where that proves true. But
Yeah, all the prediction stuff. He
well,
said
even think of
some
it
may
too.
help to some extent, but I
No, 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 no. Think of the international standards that are, created by a committee to the lowest common denominator. And often they all wanted it to be, well, we need to be able to pass this test. It was the old pass fail test. Did it work through this stress? And then it's so watered down, like drop testing, for example. You
yeah,
mentioned tumble testing for
right,
handheld phones, and I've seen those. It's basically
right,
a cement mixer with baffles in it that you're just
yeah,
banging the daylights out
yeah.
of this thing.
You got to wear hearing protection in
Oh
those
yeah, and then you open it
environments.
up, turn the phone on, and it works. It's these guys were
Right,
making robust phones, but the
right,
idea is the standards, there's no passing that test. You don't have functional products. They would have to say, all right, we're going to put it in the cement mixer, turn it by
exactly,
hand gently, make sure there's
right,
rubber foam all around it so it
right,
bounces nicely, and do that for 2 seconds. And then you can say it passed XYZ standard, blah, blah, blah.
right.
And they're so watered down. Not all of them, very many of them are. And then lots of other reasons not to like standards. But somebody said, we need to put something on the data sheet that says our product works. And
Right.
using the argument of the build test fix things is, well, we ran out of things to fix. I bet you there's still more if we had more time, but we just ran out of big things. Is not a good sales point, except for you and me in our
Well, yeah, we
esteemed
ran out of things
audience.
to
They would get it.
fix, and we feel this product is fundamental is as strong as the fundamental limit of technology can allow it to be. Okay, and we know that this is also comparable to our last phone, or
You're not
if
going to
we
see
were
that
if
in a Super Bowl ad, Kirk.
I know,
It's,
but we're talking
it's,
internal. We're talking about the internal discussions. Okay, to management and to whoever, it's an OEM. You're making a phone for somebody and whatever, and they may dictate the test requirements. But if you're developing this for somebody and you want to, shorten the time, you'll before you do their required design validation or your validation testing, which is usually showing it meets its spec and you can test it, 0C and 35C or whatever. And so the point is if those that learn to make it as strong as it can be in general, uh, early in the product phase and test it to limits to find those weaknesses is going to save them a lot of money in the long run.
yeah.
And it's just a curiosity. How strong is this? I mean, what is our problem?
What
And
could fail? It's just,
right
it's
and
curiosity. But that's what I
right,
think what the Packard was all after was you can't improve something if you don't know how it fails.
right.
Is
And
kind
I'd
of the gist
say
of it.
right, like for instance, waterproof. I mean, water resistance.
Yeah.
Okay, that's not a standard halt test, and we generally don't think about it. But now with smartphones, most of them being water resistant, I certainly hope that Apple and Samsung and all of them test that till water intrudes into the case, pressurizes. They go to 30 feet. And of course, you can just use a pressure chamber, but going in a tub of water and going up into several atmosphere pressure,
Hmm.
equivalent to several deaths, that they go to that limit. And then they look at several samples and see with dye penetrant or something like that, that they've, where the
Where
seals
the
are,
incursions are. Yeah.
where the incursions are.
No, and the issue is that, and I ran into this, is a company was making a wrist exercise band type thing, right? And they had a port on it so you could plug it in to charge it and to download data and stuff like that.
All right.
And they sold 70,000 and 50,000 failed in the first 2 weeks. And I said, what did they fail for? He says, well, corrosion. And they said, we don't understand. We tested it according to the standards that are used for watches, the Swiss standard for water resistance. And he says, let's take a look at that standard. And it was put it in 3 feet of water, like 1 meter of water, take it back out immediately, shake it off. And if it's still
Yeah.
working, you pass the test. I said, even if water gets into it and you shook it off, it's still going to work. It takes about a week for the corrosion to actually short out your system. And he says, how did you know
Right.
that? He said, because that's how corrosion on electronics and
Yeah.
moisture happens.
It's
And
a
so they
chemical
hired me on,
reaction.
yeah, they hired me on the spot and had me help them figure it all out. But they'd never recovered. They were able to stay in business another year or so, but then that mistake shut down their
Well,
company.
I know they've come a long way in the water resistance. I had an iPhone that just because I think my daughter threw a water balloon at me and it was upside down in my pocket with the power connector. It was
Yeah.
before US Lightning, I actually think.
These are the old
Uh,
USB-A's. Yeah.
yeah, and I took it to the Apple
And
store
he
and he
saw
says,
this little blue dot,
red dot. I think
red
it was
dot. Yeah.
red. And he says, that's not our problem.
You got
You've
water on it.
that was to me a way of just saying now you can, I think it's 30 feet. And I'm not going to test it in the Bahamas, but you know,
Don't drop your phone.
and especially salt water. I mean,
Yeah.
talk about the worst kind of water you can put on electronics. But that's the thing. Technology improves, it gets stronger many times, gets better, more robust by the fact that, we most of the smartphone manufacturers have addressed the main problems, which is breaking the glass. And the Gorilla
They've gotten
Glass is
way
incredibly
better now.
strong. Oh, yeah.
Yeah. Now, here's the dilemma here for you, Kirk. Right. The way many of our markets work, and there's an arc to it, even cars, right? Or cars where you needed a new one. And I want a new car in my driveway for
Right,
status. It's not that
right,
I need
right,
a new
right,
car.
right,
And I want the new phone because it's stylish versus
right.
not having the last year's
Exactly.
phone. And I want this and I want that. Now, when the first phones came out and people started adding must have features and really good improvements to speed and capability and all the other stuff, people were changing phones every year. Except you. You
Oh,
never did.
sure.
You never did. And now it's every 3-4 years. People are still, except for the ones that do it for style or whatever. But let's say that your phone, for the bulk of your revenue, for the bulk of your market, is widget A is only going to last in somebody's hands before it becomes technologically obsolete for 2 or 3
Right,
years.
right.
So how do you draw the line of this pursuit of build, test, fix to get to technological limits and say, why are we over designing this? In those cases, it only needs to last 2 years. Now you get the advantage that you get almost no warranty failures over those 2 years, unless it's the
Right,
water thing or whatever, right?
right.
But it's the argument on the other side is just make it good enough. Don't make it great. And I find that argument hard to rationalize with people when we know that 80% of our market's going to buy next year's model anyway.
Right. And that's so much technology is true with CD players, DVD players. We have such a technological evolution. Now it's just mostly streaming. So even though CDs and vinyl records are coming back a
Well,
little
we're getting
bit.
TV screens with resolutions that the human eye can't
Exactly.
tell anymore.
That's
You were
right.
talking about that
Right.
earlier.
And just like the sound back in the 70s, my electrical engineering professor would argue that you can't hear the difference in total harmonic distortion between point one and point 0.01 and point 2. So
Yeah.
why are you guys arguing all this? It's just one-upmanship, and that kind of
Yep.
thing. But my thing I talk about, and we've never really gone on to the what I consider mostly the elephant dance, is everybody estimating and working on predictions for the end of life of components and whatever. And they used to use the Arrhenius equation, also known as the erroneous equation, because it was misapplied to so many things. In fact, you'd still have to model for any activation energy. You'd still have to do hundreds of samples to
You got to
get
do the
some kind
work
of
to figure
spectrum.
it out what it
You'd
is.
have to
Yeah.
do the org, and by that time, so it doesn't. And also, the cost of building a robust product is not that significantly higher. And you don't necessarily need to use, highly rated components or whatever. Somebody asked me if they should use military grade, and I said no, maybe
No, no, hell
no,
no.
no, 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 because the military grade requires a whole bunch of extensive testing and actually may use a significant portion of the life. You never know.
Yeah.
So, just use standard components. They're pretty strong if they're built correctly.
And not
That's another
counterfeit.
problem. And they're
Counterfeit.
not counterfeit. Well, if they're counterfeit, they're not probably built correctly, but or taken from a reject pile or something like
Yeah,
that,
but
which
you're talking
happens
about
all the
issues
time.
that are at the start of life through manufacturing error, supply chain
Throughout the
errors.
manufacturing, right?
As
Tons of
those things
all the
happen,
manufacturing chains, all the supplier chains that are to make one, chip from wire lead frames to the epoxy capsulant to
the
everything that's
silicon,
silicon,
the gold
everything. There's
wires.
all of those. One of those streams could lose its process control, or
Yep.
somebody grabs a quick, thing from the back
Oh, they put
warehouse that
engineers on the floor while the staff has their annual get together. That's you never want to buy anything the engineers built.
So anyway, the end of the bathtub curve is for many, many products is irrelevant. It's not ever going to be seen. And we're really never going to know if he takes that phone and puts it back in his drawer and then comes out another 30 years if he,
Probably
lives up
still
here.
work.
It'll
Probably
probably
still
still
work.
work. Right. They've got plenty of life. And my pinball machine, as I've talked about before, has 1983 chips in it. And they're the original chips. And they were on location, probably running 24 hours, or
18
being beat
hours a
up
day. Yeah.
all the time. Yeah, it's a very well routed machine. So I'm not worried about those chips failing. I don't think they're ever going to fail.
It's more the
And
actuators, the
there's
coils.
exactly all the mechanics. We talk about that. Definitely limited because they use materials, they're consumable materials, in the sleeves and the solenoid piston and plungers and things like that. And also, they shake. They got a lot of vibration. That's why solder joints sometimes fail in them. And but they don't get a lot of thermal cycling other than their own self-heating.
Yeah.
Um, so, it's just if you look at the perspective, for the most part, the most expensive problems for a company are in the beginning, at the front end of that bathtub curve, where you've introduced a product and it starts failing in the field.
Yep.
Okay. And it's always a learning curve with any manufacturing product
And
line.
it doesn't have to be. I've worked with some teams that, we paid attention to where are
Right.
the risks
Right.
in our supply chain and assembly processes,
Right.
and let's get those under control. And it pretty much just that attitude of pay attention to where it came from and how it's built and
Right.
make sure it's stable. It's consistently stable and especially when we're doing volume stuff. And even
Right.
workmanship standards, how do we make sure that somebody is not doing this to 8 hours a day and is just blind to what they're doing and it leads to mistakes. The human factor is part of assembly counts too. And
Yeah.
but we started doing that, and one of my clients then said, I got called back for their next project to help them get that going. And I said, so whatever happened with that first project we were working on? They all got real quiet. And I'm like, well, I don't think I'd be here if it was a disaster. He says, no, we actually had to call our customers to find out if they even turned it on yet or not, because we hadn't had any reports of any failures for the first 2 months.
Yeah.
And this is when I was talking to him, and he says that had never happened in our launches before. It was all hands on deck for 2 months.
Yeah. Well, engineers do design robust products without ever going through stress testing. And I've seen them, a new product also have very good margins, significant, and doesn't
Yeah.
need anything. But that means I've got lots of strength to use to find those manufacturing defects when we start
Yep.
to pilot and
Yep.
early runs. And that's what I need to do. And if I don't find them, and of course, manufacturing can change at any time.
No, no,
Anybody
no.
can lose control.
The design is
So,
solid. Design solid. It'll be
you know,
anybody can build it. Just throw it in the bag and shake it up. It's good.
yeah, you've got to trust your suppliers and all that and have
Yeah.
them have some monitoring of their own things. But A lot of our standards are, I know the IPC standard for solder on a FET mounted FET on a board on with its heat sink.
Hmm.
I used some of the boards that I thermally cycled for thousands of times while they were operating had uh, did not meet that specification for voids. Okay.
Hmm.
It had a lot of voids, but even with those voids, it didn't cause failures in the 2,500 or more thermal cycles from -10 to +65 that I'd put these computers through. They didn't
Yeah.
fail. So we don't even know if those standards, and we're never going to know because, again, I don't know if any solid state electronics is still in use from the 1970s or 80s. It's still uses other than my pinball machine and others.
Oh, you got to come out
They're
here.
using,
We have the Computer History Museum. They got, you know, they have stuff, old
yeah, and I'm
Heathkits
sure
from the 70s.
The first
First
Apple
Apple
computers are
still
still
work.
would be able, yeah, they're still boot up. And I've had
And the computer
motherboards.
would look at you go, Internet?
Well, and
What?
I put some of those boards after I ended the experiment of thermal overstressing, and you can go find my paper on my website. I'll put a link to it. But on thermal overstressing of bit of standard PCs, and I put those away in storage. I put them in a card cage or in a wire cage to hold them just for reference, and later if I wanted to
Hmm.
look at them. And then I took them out. And I said, "Well, I wonder if these things will boot up." After they've been through thousands of cycles from -10 C to 20 to 165 C. One of these things will still boot up, and as they've been in storage, I was sitting here, and I booted them up, and the clock was still running, and it was only off by a few hours, and I had set that as a side, and this was over a 3 or 4 year period. Well, I'm expecting, yeah, after that
Total
many
failure. The
years,
clock's out.
yeah,
The
exactly.
clock's off.
I'll give it up. The clock's off after that year. That little battery was running, and I never replaced any of those batteries.
Wow.
Uh, the little nickel battery, and so
Yeah,
I think they even withstood that for
yeah.
years.
Well,
So
yeah, this stuff lasts. So next time you buy something, buy what you want and want to live with. And if you're not if you're fashion challenged like me, you won't need a new phone for a
and
decade.
and do not buy an extended warranty.
Oh yeah, no, don't bother.
What a waste of time, waste
Well,
of money
the
that
companies
is.
make a lot of money at selling
Oh,
those things.
it's
So
not a waste of money for them.
no, no, you got to think of the other side.
Whether they'll be in existence, 7 years from now.
Yeah. So
You won't even know.
it's got to do shout out to Stefan. Thanks so much for the story and hope the shindig, your 25-year anniversary for the project you worked on went well and you have fun with that. But I knew I had to talk to you, Kirk, because you would, tie right into this. You go, yeah, electronics are solid. Don't worry about it too much.
Yeah,
Have
yeah.
a good time. If designed well and the build test fix part comes right into it and so on. So, but if you're listening to this, if you got an interesting story of something you pulled out of the shelf and it came right back to life or unexpectedly long lifetime, we really need to find somebody at JPL that dealt with it. Was the Curiosity rover was like 20,
Yeah,
15 years and expected
yeah.
6 months or
Or how
something.
about the Voyager that's still out there, billions of miles from Earth,
Yeah, talking away
still
and
talking to us and an incredibly low, what it takes about 7 hours for us to reach it in the
yeah,
communication link or something
yeah.
like that. It's just phenomenal
But
that
it's things can work and we can be
yeah,
pleasantly surprised sometimes by it, and other times we're dumbfounded. Why is this not working right out of the box? There's a pretty good
right.
range of things that go on out there. But if you've got a cool story like that or have a question in general about reliability and related fields, let us know. We're always interested in what you got going on and what's on your mind. You can do that over at accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. And Kirk and I and the other hosts are available through LinkedIn and our about pages. So lots of ways for you to become involved with the chat that we do on these shows. So with that, Kirk, I don't think I have any old electronics laying around. I went through a big purge of e-waste a couple of years ago. I bet you I
Yeah,
can find
well,
something.
getting the adapter plugs and, the right interface, that's to power them up. I've got some old phones. I don't even know if I can do that, but there's nothing for them to do. I have old PCs that still work, but they're technologically obsolete. I can't really do anything with them. They
Well,
just,
put them on the counter for a weather station,
yeah, something like that. I know. So, all right, let's talk again.
All right, will do, Kirk. Talk to you soon. Cheers.
Okay, bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.